But here is the twist. Although the vast majority of the action is and will be on inference, GPUs are actually quite bad at it. And here is why. During the process of inference, only 5 to 7% of the GPU is actually utilized. It's really like building a gigantic factory that can output 10,000 cars every single day, but actually you only need 3 cars per day. This is what is happening on GPUs at this moment. Only 5 to 7% of GPUs are utilized during inference. That's crazy. But why is that? Well, fundamentally it's because of the batch sizes. In fact, GPUs are optimized to have big batch sizes, but you really cannot wait 500 and plus queries when you ask something to ChatGPT to wait to get an answer. You want an answer right away. So we know latency is very important. You ask ChatGPT, what's the latest news about Trump? You want to know it right now. You don't want to wait ChatGPT to cluster 500 plus queries from different users and then process them all together. That's not realistic because you will have to wait. You would have latency, but you don't want that. And that is why the critical problem with GPUs is not really a computing problem. It's not a matter of throughput. It's really a matter of moving data. So it's a memory problem. This is why GPUs struggle so much on reasoning and agentic systems. AI agents are like a single player mode, whereas GPUs are really built for stadium gigantic crowds. Or said a little bit more technically, agents are latency bound. They are not really throughput bound. You care about having a response on time. You don't want to wait to reasoning for minutes. You want an answer right now. Or again, said differently, it doesn't really matter the tokens per second in aggregate, which is what GPUs are really good at. But you care about how fast you can generate one token for one user. GPUs are really designed for batch processing and maximizing throughput. But they really choke when they are asked to do something high speed for single stream inferences.